Hi guys, today we're going to do section 1.2, operations on rational numbers. So let's start with some definitions in order for us to move on for this section. So absolute value, please write this down. The absolute value is a number's distance from zero. So absolute value is always positive. Does not mean that you are making things positive. Absolute value is distance. So for example, if you were asked to find the absolute value of -4, the symbol is these two vertical lines around what you are evaluating. -4 is located on the number line right here. The distance -4 is from 0 is 1, 2, 3, 4 units away. So the absolute value of -4 is 4. The absolute value of, let's say, 5. 5 is right here. Distance away from 0, to get from 0 to 5 is 5 units. So the absolute value of 5 is 5. Exponents. A to the n power means A multiplied by itself n number of times. So A times A times A. The number of A's here is n times. So A to the 4th power would mean A multiplied by itself 4 times. This number right down here, the bottom number is called the base, and the top number is called the exponent. Order of operations. PEMDAS. P-E-M-D-A-S. I write it this way. Make a note of these two right here, M, D, and A, S. Take a minute and write this down. Multiplication and division. It is whatever one you find first, coming from the left to the right. So they are on the same equal playing field, and same thing with addition and subtraction. We need order of operations in order for us to have a set of rules in order to evaluate expressions. So let's take a look at number 1 together. And let's go down through the order of operations. There are no parentheses or grouping symbols, so our next step would be to do exponents. So 6 squared is 36. Rewrite everything here. Next step is multiplication or division, whatever we see first from left to right. So we multiply 3 times 2 is 6. Next step would be multiplication division again from left to right. So -6 divided by 2 is 3. -3, so we keep subtraction there. And we are finished with multiplication and division. So now 14 minus 3 plus 36. Subtraction comes first because it came first coming from left to right, so 11 plus 36. Our final answer would be 47. Alright, so take a few minutes and go through order of operations to evaluate and simplify numbers 2 and 3. Alright, take a few minutes and check your work here. Number 2, we had to do division first, from left to right, then multiplication, and then go back and do addition from left to right. You can add all 3 of these up at the same exact time. I just broke it down into 2 steps there. So your answer for number 2 is 37. Number 3, we have parentheses first. I kept my answer in parentheses here. You can take it away. Just be careful if this is subtraction out here and whatever is simplified in the parentheses, if it's negative, just be careful of signs. Then exponents, so 5 squared. Then multiplication or division from left to right. So be careful, do 3 times 25 first. And then -10 divided by 5 is -2. And then add and subtract from left to right. So number 3's answer is 81. All right, we are going to go back and think about what we learned in section 1.1. dealing with real numbers and go through and decide if these are true or false. It is easier to prove something false because all you need is one thing to prove a statement false, and that one thing that proves something false is called a counterexample. So please write that down. Number 4, the absolute value of any real number is greater than 0. So let's think, what represents real numbers? The set of all real numbers is the number line, so it includes rational and irrational numbers, positive and negative numbers, and also 0. So can we think of anything that would have an absolute value not greater than 0? If you said 0, you are correct. So our counterexample is 0. So this one here is false because the absolute value of 0 is 0, and that is not greater than 0. And that is actually the only one, but all you need is one to prove something false. Take a look at number 5. The absolute value of any real number is equal to the number itself. Take a few minutes and try out some examples there. So what they're saying is the absolute value of some number. We're just going to call it A. Why not? Plug in a few examples and see if that example is true or false. If you said false, you are correct, because if you were to plug in any negative number into your true-false statement here, into your statement, I should say. We don't know if it's true or false yet. If you do the absolute value of the absolute value, when you have two absolute values, you always go from the inside out. That is also the case when you are dealing with PEMDAS and you have two sets of parentheses. You always start with whatever is inside first and then work your way out. So I did a couple examples here. The absolute value of 5 equals the absolute value of 5, which is 5. So this answer is the same as your original number. Same thing when you plug in 0 here. However, whenever you plug in any negative real number into the absolute value of the absolute value means distance. So the absolute value of -2 is 2, but the absolute value of 2 is also 2. So these two are not equal. So this one here would be your counter example. So 5 is false. Number 6, the absolute value of any real number is equal to the absolute value of the opposite of that number. So what it means to be an opposite would be multiplying by a -1. So for example, a 5 and its opposite are -5. So take a minute and try some examples there to see if that statement is true or false. Alright, so number 6, any real number, that real number. So I start with a positive, so the absolute value of 5 is 5, and 5's opposite is -5, and the absolute value of -5 is 5, so these two are equal, so that one holds true. Same thing if you start with a negative number, -10, the opposite of -10 is +10. They both have an absolute value of 10, so that is also correct. And just for the sake of people being confused with 0, 0's opposite is 0. We multiply 0 by a -1, it's still 0, so that holds true. So number 6's answer is true. Alright, we are going to review some ideas from section 1.1. We are going to do 1 and 2 together. Remember, U means union, or, and this N means and, so this means the intersection, and means both. Make sure you write that down. Alright, number 1, we are taking the union of these two intervals. So let's graph to see if they have any overlap or if they stay as two separate pieces. Go ahead and graph both of the intervals in number 1 on the same number line to see if there is overlap. Alright, so number 1, in blue I did -infinity to 5, And in green, I did the interval 1 to 7. So for union, union means or, so it needs to satisfy at least one or the other of either blue or green or both. So you're taking everything. So in this case, we have the interval negative infinity to 1 is just blue, and then this piece which is double shaded, and this piece which is just green. It is all one piece. There are no two separate pieces. So for the union, you can simplify this to be the entire interval. See if I can get this. The entire interval negative infinity to 7. So the final answer for this one would be negative infinity to 7 with a parenthesis because that is the symbol that is with 7 at the time. Intersection is more specific in the sense that it needs to satisfy both of the intervals. So we are looking for when it is both shaded. So in this case, in number 1, if that question was intersection, we would only be taking what is green and blue. So this piece right here, 1 to 5, parentheses 1, comma 5, bracket, if that was intersection. So go ahead and take a minute to graph both intervals in number 2 on the same graph, and then look to see where there is overlap, if there is any. All right, for number 2, this is the graph of both of the intervals in number 2 on the same number line, and we are looking for the intersection, so we are looking for what is shaded both green and blue. So this piece here has nothing. This piece here just has blue. This piece starting at 5, including 5, has green and blue all the way to the arrow, including the arrow. So what would that final answer be for the intersection of these two intervals? If you said 5 to infinity, you are correct. Remember, infinity is a parenthesis. Another thing to note, if there is no intersection, meaning if you have two pieces of your graph that do not overlap and you are asked to find the intersection, your answer would be no solution or the 0 that's slashed through it, which means the null set, meaning there's no number that satisfies that question. All right, so please take a few minutes and try out these 3 problems. Remember that the subtraction sign means you are taking away the interval that comes after it. So you are graphing this interval first, and then you are removing this interval away from it. So go ahead and take a few minutes and solve each of these problems. Graph your work first, and then write your answer in interval notation. If it is 2 pieces, remember to use U for union. All right, so, excuse me. All right, so I graphed 3, 4, and 5. I have not answered them completely yet. Number 3, the red interval is the first one, the blue interval is the second one, and we are looking for the intersection, so what is double shaded. And you take on whatever symbol, parenthesis or bracket, that is attached to that number that is the end point, the critical point of your shaded, double shaded region. So the answer to number 3 would be the section that is blue and red. So from 2 to 5, so bracket 2, comma 5, parenthesis. Negative 4 through 2 is only single shaded of red, and 5 to 6 is only single shaded of blue. Number 4, the blue region is the original, and you are taking away the red. When you do this, you are taking away a bracket. So this is a bracket here, so it's going to be a parenthesis going the opposite way. Here they're not taking away 12, they're taking out all numbers up until 12, so that's going to be a bracket, and you are keeping all of the blue that does not have red. So this is 2 regions right here. So our final answer for this would be negative 8, comma 5, parenthesis, union, because it's 2 pieces, starting back up again at 12 to positive infinity. Using that same mentality from number 4 for number 5, parenthesis at 3 has a bracket, bracket at 11 changes to a parenthesis, and you are shading in anything that's left over. I hope this was helpful. Let me know if you guys have any questions. Have a great day. Thanks, guys.